IPv4, also known as the fourth version of Internet Protocol, is the core protocol that routes most of the Internet traffic. This is a connectionless protocol, which means that the state of the connection is not preserved, and the data is transmitted to the receiver without ensuring that the recipient is available. IPv4 uses 32-bit addressing, which allows a total of over 4 billion IP addresses. Some addresses are reserved for public and private networks. An IP address consists of 4 octets, which are separated by a period, which is also known as dotted decimal notation. Oct meaning 8 is used because the value of the octets is 2 to the 8th power. For example, the IP address 192.168.0.1 represents 4 octets. Our IP addresses are made up of these 8 bits. You can see a representation here. They can all be ones or zeros or any combination. These ones and zeros have decimal numerical values. The number 1 is represented by the binary number you see here. It can be a bit confusing, but the numbers add up from right to left. Let's take a look at this further. The 8 bits of ones are translated into decimals. As you can see, the bit all the way to the right represents the number 1. As we go left, we double the numbers until we get to 128. If you're using the power of 2, you'll notice that they add up to 255. Why not 256? Well, that's an easy answer. It's because we start with the number 0 and the max number goes to 255. That is a total of 256 digits, although you only see 255 in the scale here. Binary is either a 1 or a 0. There is nothing else. We're used to decimal, which is 0 through 9, so scientists converted the binary invention of IP from binary to decimal to make it easier to read. Why is it 1 or 0? It's very simple. When you turn on your blender, it's either on or off. Your blender works in binary. 1 is on and 0 is off. Many electronic devices even have a 1 and a 0 on their switch. Computers are the same thing. They're made up of a whole bunch of on or off switches, billions of them. When you type the letter A, you set in motion hundreds of thousands of tiny gates that are a series of on and off switches like a light switch that flip in order for that A to appear on your screen. It happens at almost the speed of light. In the 1950s, many different scientists created their own language, also known as a protocol, to allow their computers to talk to each other. It made it really confusing. Finally, the U.S. Department of Defense came up with the perfect protocol, and they paired it with a connection-oriented second protocol and called it Transmission Control Protocol over Internet Protocol. Now computers could communicate with each other regardless of brand and model, and they could communicate with groups of computers we eventually named the World Wide Web.